let's continue. Let's talk about exponents. Ne? Exponents, exponents, and what? And surds. So now, when we talk about exponents and surds, ne? Or surds, you'll get a, and then it will just be having maybe an x here. Now, this is your exponent, and then this is your base. So now, if this is your base, this just means like an exponent just means that it's just showing you how many times a number or the base is being multiplied by itself. That's the thing. Yeah? And then a surd is a number that cannot be simplified further to remove the root. For an example, you might be having a, maybe the square root of something like this. So the way in which you can simplify this is just a matter of you maybe just saying, hitting your calculator there and then getting an SD so that it can give you decimals in everything. But maybe let's say this is a 4, but for 4 we know it's just a 2. But when we come for the square root of 2, if you are to hit your calculator, it can just give you again the square root of what? Square root of 2. But other than that, you can just say what? You can just hit SD and then it will give you a certain what? A certain number. A certain number which can be 1 point what? 1.4142, something like that. You see that? So now that's just the surds and also what? Exponents. Now going further on the surds, you find that there are ones wherein they've got how can I place it? They've got a square root. Like maybe like what I just did here, the 4 has got a square root. But you might also find that sets have got something like this. Their formula I think is more like something like this, where in n it just means the root number. You see, like maybe we want the square root, fourth root, third root, something like that. In most cases, you find that okay, this number, when this thing is more like the same as a to the power of 1 over n. Do you get it? Wherein, like now, if you are given a number like this, square root of 3, this thing is the same as a, 3 to the power of 1 over a 2. And then something like this 3, it's the same as 3 to the power of 1 over 3. And then even something like this just the same as what? 3 1 over a 4. Do you get it? So now after getting this, for the exponents, when we are talking, if okay, because I'm still talking about set, let's say that you come across a set in a what? A set in an equation. For you to be able to remove a set from an equation, you need to square it. Not necessarily square, but you need to place an exponent which is of the same what? Root here. Let's take for an example, you're having a 4 here and then a 3 here, and then the equation is something like this. So you trying to remove this root here, it just means you'll be having what? Okay, this is the same as 3 to the power of 1 over a 4, meaning you trying to remove this 1 over 4, you need to raise to the power of 4 and then also raise the x to the power of what? Of 4. Do you get it? Knowing for a fact that the 3 and 3 will cancel, and then you just be left with what? With x is equals to a what? A 3. I'm just trying to what? Explain to you something which you will come across when we what? When we proceed. And then now when we are going back to the exponents, for the exponents part, when exponents no exponents, yeah, when we talk about exponents, if the bases are the same, like you're having a multiplied by a, which means this will just give you a squared. If now you are having a maybe let's say this is 1 here divided by a squared. This will just give you a 1 minus a 2, which this thing will just give you a minus a 1, which a minus a 1 is the same as 1 over a. Do you get it? But now if we are talking about something like a multiplied by b, it will just give you a multiplied by b, and then that's it. And then there won't be addition of what, of exponents, because the bases are not the same. Do you get it? But now let's go to a situation wherein maybe you find you're having a, and then it's maybe to the power of 4 is equals to um, and then maybe a to the power of x. Now the bases here are the same. Okay, let me use numbers because you're going to come across numbers in most cases. You're going to get, let's say you have 2 to the power of 4 is equals to 2 to the power of x. Now the bases here are the same. It means, because like here we are talking about equations, you'll say x is equals to what? Is equals to a 4. Now if you encounter a situation wherein you are having what, you are having what do you call this thing, you are having exponents which are the same, it means the bases should be equal. You should equate the bases. Let's say now you are having 4 to the power of 2 is equals to 2 to the power, no, okay, no, x to the power of 2. Now the bases are the same, you can just equate it there. You know, the exponents are the same, meaning you can just equate the bases. Do you get me? And then that's it. And then now uh, doing an example, you'd find that for exponents you'd get what's this, do I still, okay, I don't have a space. You'll just have what, you'll just have 27 maybe. 27, for an example, if it's saying to the power of 1 over 3, this is the same as you saying 23 to the power of 3 and then 1 over a 3. Do you see that? Then this will just give you 3 and 3 cancel each other, you're left with a 3. Do you see that? And then also you might find a situation wherein you are having 3 and then 3, not 3, yeah, but 3 is fine, and then something like this. So once you have something like that, you can say maybe to the power of 3. Here you can just say this is the same as what? This is the same as, rewrite this thing as a fraction. You'll get 27 over an 8 to the power of what? To the power of negative 2 over a 3. This negative can make allows you to reciprocate. You'll say 8 over 20 what? 27. Do you get it? The negative, because this is the same as this, man, is the same as you saying let's just only take negatives. You'll be having 27 to the power of negative 1 and then 8 to the power of negative 1, which this thing, we are only considering the negatives, né? Which this thing is the same as 1 over 27 divided by 1 over an 8, which this thing is the same as 1 over 27 then divided by 1 over 8, which this will just give you what, 1 over 27 multiplied by 8 over a 1. That's why you're having this. Okay, so then that's it. And then moving on, it just means you'll be having to the power of what, 2 over a 3. 2 over a 3, this is the same as 8 is the same as what, 2 to the power of 3. 27 is the same as 3 to the power of 3, and then 2 over a 3. Now the 3's can cancel there. Do you see that? This 3 and this 3 and this 3 will cancel that, and then you'll be left with just